This is the narrated PowerPoint on Rhetoric of Science and Contemporary Metaphor Studies. So from your reading for this week, you read some short passages from Friedrich Nietzsche. And interestingly enough, if you know anything about Nietzsche, you know him as a philosopher. He was also a college professor. He was a philologist, which was someone who was interested in the history of language. And he gave a couple of, he gave a seminar on rhetoric. And in the seminar, he had some lectures on metaphor. And it was a very small class. Only a couple of people signed up for it. But one of the people who signed up for it was so impressed with it that he took detailed notes, and this is what we have from this portion of Nietzsche's scholarship. The student kept his notes, and so that was what you read for part of your reading for this week. And so these three quotes are very important here. What he's saying is that all language is metaphoric. He's saying not only is all language metaphoric, he's saying all thought is metaphoric. And that's a radical departure for the way that metaphor had developed in rhetorical studies since the time of Aristotle. You remember we were looking at last week at Aristotle's work and how he found metaphor to be at the seat of language. And that has a good deal to do with our very being. But Nietzsche himself, I think, by calling all language metaphoric, is very much acting as an Aristotelian, even though it was a rather radical departure for the way that metaphor had developed, because as I was saying, is that, what had happened just a few hundred years later is that the Romans were looking at metaphor as largely decorative, and that's the way it was being treated in handbooks as well. Now, Nietzsche was 19th century. Chaim Perlman and Lucy Albrecht-Steidecker are 20th century. Chaim Perlman actually was in the Belgian resistance during World War II. He was Jewish, and he managed to survive the war by staying in Belgium and fighting the Nazis there. Lucy Albrecht-Steidecker was she had the equivalent of a BA, but their book, The New Rhetoric, is still considered to be a contemporary classic. It was published in French, I believe it was, in 1958, 1959, and then in English in the mid-1970s. Well, they didn't actually come up with the idea of naming the different parts of a metaphor or of an analogy, and the terms they use are theme and phoros. So far as I know, the person who actually started first doing that was I.A. Richards, but he didn't do nearly as much work on rhetorical theory. If you're familiar with Richards, you probably know him as a scholar of literature. But Perlman and Albrecht-Steidecker devoted themselves to rhetorical theory, and their book, The New Rhetoric, I gave you the table of contents so you can see how long and how detailed it is and where metaphor falls in their studies. You see, it's very central. Okay, this concept of theme and phoros is important. The theme is the idea to be explained, and phoros is the metaphor that enables the explanation. And we see this in science all the time. So, for example, with the metaphor, an atom is a miniature solar system. The theme, the idea to be explained, is the atom. The phoros is the miniature solar system. That's the metaphor. that's being used to explain the structure of an atom. If you know more about contemporary physics, you'll know that they're no longer believed to be, the subatomic particles are no longer believed to be in regular orbits around the nucleus of the atom, but it's a useful analogy, and you see it in grade school texts all the way up through high school as a starting point for explaining the structure of an atom. And the thing is that the subatomic particles are not in regular orbits. They are predictable as to where they may be, but they're not in the same types of orbits that the planets are in. And then the second one, same idea, but it's is a model for the A is to B is C is to D template. And here we have as the planets orbit the sun, that's the phoros, that's what's going to be used to explain the structure of the atom. The subatomic particles orbit the atom's nucleus. So what's important here is this idea of taking the metaphor or the analogy and breaking it down into parts and naming them. And that enables rhetorical theorists to talk in more detail about metaphors, about atoms and so forth, and how they're structured and how they work and all that sort of thing. Today, where the most work is going on in metaphor studies, and if you notice the opening slide, I had the term metaphor studies. That's an actual field of study, and it attracts people from a variety of different areas. Linguists are very heavily involved in metaphor studies. As I mentioned before, a big issue with artificial intelligence is explaining how metaphors work. And these are, as children, we learn how metaphors work and what's literal and what's figurative and so forth. But artificial intelligence has had more of a problem with understanding that. So that's one reason that it's important right now. So is this just something that English language scholars are basically interested in? Well, no, it has a relationship with science as well, and there's a very long relationship between metaphor and analogy and the sciences and engineering. John Smeaton was a 17th century British engineer, and he was put in charge of building a new lighthouse on the Eddystone Reef. The two previous ones had been swept away. The first one was built like a column, basically. It was as wide at the bottom as it was at the top, and that was very quickly, it only lasted a couple of years. It was very quickly snapped off. And so the next one was shaped like a cone. And so it very gradually narrowed up towards the top, but it too was too fragile. Again, only lasted a year or two, and it was snapped off and destroyed. So Smeaton was thinking about how he would go about designing a new one, and we know this from his journals that he kept. He was out walking around and thinking, and he thought, well, maybe he could build it like a ship, and the lighthouse would rock back and forth. He thought, well, no, ships capsize. He thought, well, maybe he should make it like a baby's cradle. And he thought, well, no, there's that nursery rhyme about the bow breaking, and cradles can be tipped over too. And then he said, as he was out walking, he looked up and he saw an enormous oak tree. And he noticed how, even though it was subjected to many, many storms over the period of its life, they very rarely would get uprooted or snapped in half, you know. And what he knows about the design is that in some ways it was like a cone, but the narrowing of the column took place much more gradually. And so that's what he used for his model. Well, this lighthouse on the Eddystone Reef, and this was in England, stood for 250 years. It finally had to be removed because it could no longer be used. All the rock around it had eroded out from around it. So it was different, when the tide was in, they couldn't even get to it. It's still standing today. They moved it inland a few miles, and then they built another lighthouse out on the reef, something that has more with electronics and so forth. But the point is that this isn't just English teachers mucking around with theory. It's something that has very real and practical applications and is of interest to scientists and engineers as a part of their work. Of course, a problem that we have with the sciences is that a lot of times metaphors can come into play. They can kind of leak over from pop culture. And of course, George Lucas very wisely named one of his Star Wars movies Attack of the Clones. And the Star Trek movie on the left, that fellow on the left, is Captain Picard's clone, and he's struggling with whether or not he's good or evil. Invariably, clones are evil. And this idea of cloning is a kind of a metaphor that we're still dealing with in our culture. And that was something that I took up myself, and that you'll be able to read in more detail about. Now, one effect on international politics in terms of cloning is that in 2005, the United Nations banned all forms of human cloning. And if that had been actually carried out, it would have brought all cloning research to a complete halt. I don't know to what extent you're aware of this, but President Clinton had supported cloning. President Bush limited it. He didn't stop it altogether, but he wasn't allowing any new lines to be developed, and that limited the amount of research that could be done. Now, speaking of popular culture, in 2005, something else happened. This movie came out, The Island. Some of you may have seen it. In the movie, these two clones that Ewan McGregor and Scarlett Johansson play, they discover that they are being raised as a spare self for spare parts for wealthy people. And they try to escape the island where they're held. Now, there were some Gallup polls taken around that time, and this was a question that they asked. In general, is medical research using stem cells obtained from human embryos morally acceptable or morally wrong? The reason they were doing this is that the stem cells can best be harvested from human embryos, and what scientists were doing was getting them from fertility clinics. These were human embryos that otherwise would have been destroyed. They'd been fertilized, but they weren't going to be used. They were just going to be destroyed. But it upset a lot of people. Okay, but anyway, in terms of the response to this question before the island, which remember was 2005, about 52% said it was morally acceptable. 39% said morally wrong. 2% said depends upon the situation. 1% said not a moral issue, and then 6% had no opinion. After the island, morally acceptable rose almost 10% to 61%. Morally wrong, dropped 9 points to 30%. Depends upon the situation, went up a point somehow. And it came from not a moral issue, I guess. That had 0. And then no opinion was 6%. So, point is, popular culture can have an effect upon metaphors that are being used in the press. Now, these are the actual clones that we're talking about. These are the animals that have been cloned so far. The one on the left, the lamb, is Dolly. She was cloned in 1997. We'll talk more about her in the middle in a moment. In the middle is the adult sheep Dolly, and that's her lamb that she gave birth to. She did die. She didn't live quite as long as she should have. The reason she died of a lung disease. The reason she got the lung disease is because she was kept indoors. The reason she was kept indoors is because they were afraid somebody would steal her. I guess that's something someone would want. um, and on the right is the cult Prometheia, named after Prometheus, who you may recall from classical literature stole fire from the gods and gave it to humans. But a horse is the largest animal that has been cloned to date. Here's how Dolly was cloned, and this might provide a little bit more insight. But her mother is, in terms of the her genetics, came from the one that's in the middle there, the white-faced sheep. What they did is they took an embryonic cell, an egg as they call it, and they extracted the nucleus. And then from the black-faced sheep, what they did is they took an embryonic cell and extracted the nucleus. And then from that egg, they put the nucleus from the white-faced sheep, that's actually called a Dorset sheep, into the egg shell of the black-faced sheep. And then they put the egg with the nucleus from the white-faced sheep into the black-faced sheep. And she subsequently gave birth to Dolly, and you can see that she was a Dorset lamb. She did pick up a little bit of DNA from the sheep that actually had her in her womb, but basically she was a Dorset sheep. And this is what has created the cloning revolution and the stem cell revolution, that we now have what we're working on is being able to edit DNA. And this will enable us to treat people with genetic illnesses. And something that they have been working on is, developing organs. Somebody needs a new liver. Rather than having to do a transplant, you get a liver grown from your own DNA. That's also just a step in the process. What they actually eventually want is just a medication that you take, so that someone who needs an organ transplant doesn't have to go through surgery. They just take medication, and their organ is rejuvenated. So this interested me. This is a cloning. This cloning of the sheep Dolly was a scientific revolution, and typically scientific revolutions have had metaphors or analogies that have been used to explain them. And of course, the stem cell revolution was having a great deal of trouble getting funded, and having funded limited, that sort of thing, and being banned. So I wondered, well, what was the central metaphor, the central analogy for stem cell research? For example, Charles Darwin, for his theory of evolution, he came up with the analogy of a breeder, to explain how an aspect of evolution works. And people at that time were more opposed to the idea of evolution than they are today. Today, for example, if you were to go up to somebody who was opposed to evolution being taught in schools, for example, and say, "What type of a creature are you? Are you a reptile? Are you an insect? Are you a mammal? Are you a bird?" Invariably somebody like that would say, "Oh, I'm a mammal." You say, "Why are you a mammal?" You say, "Well, females of my species give live birth, and then they nurse their young, and I have hair," and things like that. Well, at the time that Darwin was trying to write about the theory of evolution, there were people who believed that human beings were not mammals, they were something else. They were a separate species. So much more hostile environment. Darwin had an analogy. What I found out, what I discovered, is that in stem cell research at the time of the birth of Dolly, and then what was written about her, the scientist Ian Wilmot, who wrote about her, there was no central metaphor. There was no central analogy. What I found most often were what I referred to as technical metaphors, and technical metaphors could be used to do something like describe a process. And this was not something that was new science, and it wasn't even, I would say, a scientific metaphor like we were dealing with an atom as a miniature solar system. These metaphors were deprogramming, programming, and reprogramming, and I call them technical metaphors because they come to us from the field of computer science, and they were being used to explain how the nucleus of the cell readjusts itself to being placed into an egg that was not the one that it originally came from. But that was it. And even at that time, in 1997, there were much fewer people were using computers. Much fewer people had computers in their homes. I was using one at work at that time, and I didn't have one in my home, for example. And so the point is that even computers, as the basis of a technical metaphor, were more foreign to the experience of more people. And it was my argument that because no one came up with a central metaphor, perhaps even using again the breeder analogy, that was part of the reason that stem cell research had such a hard time initially. And this is important. It's not just scientists doing science for the sake of science. There are something like 14,000 people who need transplants every year just in the United States alone. And if they could be helped by stem cell research, and many of them are now being more so helped by stem cell research, then they should be, or at least in my opinion. So anyway, the article that I wrote that you're going to read for this week was actually one that I wrote while I was working on my PhD. It eventually became a chapter in my dissertation, and then after I finished my dissertation, I was able to publish it as a book. I had to go through quite a bit of revision. People, when I use the article that you're going to read for this week as a chapter in my dissertation committee wanted lots of changes to it. When I wanted to use the chapter for my dissertation as part of my book, the editor that I was working with wanted lots of changes to it, so went through a lot of changes. And today, if you want to read more about this topic, there's an electronic copy of my book in the Georgia Southern Library. Questions? I'll see you online.